We saw in the previous video that the derivative of the natural log function is equal to 1 over x, right? We used implicit differentiation on e to the x, essentially, e to the y, and got this result. I want to look at this now in conjunction with the chain rule because it's particularly nice. That is, for example here, if I've got a function that looks like this, try this one more time here. F of x equals the natural log of, let's say, 3x plus 7. I want to take the derivative. Well, whenever we had a derivative rule that was just of x, there's a corresponding derivative rule in terms of u, right? That the derivative of natural log of u with respect to x is take the derivative with respect to u and then multiply by du dx. This is just the chain rule. Anytime you've got a function inside of a function and you're taking the derivative, you take the derivative of the outside function, leaving the inside alone, and then multiply by the derivative of the inside. So from the point of view of the natural log, this 1 over u is just 1 over whatever was in there. So this is just 1 over 3x plus 7, and then I have to multiply by the derivative of 3x plus 7. Well, that's easy enough to do. 3x plus 7, the derivative is just 3. So I end up with 3 divided by 3x plus 7. This is actually really nice. Let's do another example. How about the derivative of, let's say, e.g. here, the derivative of, so g of x is equal to, let's just do the natural log of x squared. Then g prime of x is equal to, well, the derivative of the natural log of something is 1 over that something times the derivative, well, then the chain rule says times the derivative of what's inside. Well, the derivative of what's inside is 2x. So this is just 2x over x squared. Now, it's possible that this sometimes can be reduced. In this case, it definitely does. It's just 2 over x. But that actually makes me think of another thing, that we could have done this problem a different way, because there's a property of logs that lets us take the log of x squared and turn it into 2 natural log of x. And so then taking the derivative of this would be the same as taking the derivative of that, but this is just a constant times a log, and so the derivative would be the constant times the derivative of that log, and that's exactly what this is. Right? But in general, if you've got y equals the natural log of a function, then the derivative is 1 over that function times the derivative of that function. It just looks like f prime of x over f of x. This is particularly easy to do. Whatever's in there, you just put it on the denominator and then take the derivative as the numerator. One more example here. If I had y equals the natural log of the sine of x, then the derivative is, I'm going to have 1 over the sine of x on the, so the sine of x goes on the bottom, and then the derivative of the sine of x goes on the top. Oops. The derivative of the sine of x is the cosine of x. And cosine of x divided by sine x happens to be the cotangent of x. So the derivative of the natural log of the sine of x is the cotangent of x. Okay. This is something that we're going to use in the next video to exploit the properties of logs, and the easiness of taking derivatives of logs of stuff in order to take derivatives of some really complicated functions. But that's in the next video.